Hello everybody, welcome back. I'm Jyoti and today I'm going to show you how to get the geometry of a STAAD model into an Excel format. For example, suppose this is the Excel sheet and I want the details of these members. That means I need the coordinates of the ends, I need the length of the member and the property which we have assigned for it. I want this information in a tabular form. Okay, so suppose this is my format. First number means beam number I want to tabulate in this column, then section which we have used for those beams, then length of that beam, coordinate A and coordinate for node A and node B, XYZ, XYZ. So here we are going to populate the information from STAAD directly through OpenSTAAD. I forgot to tell you one thing, most important thing in my previous two tutorials, that whatever I'm doing programming here using OpenSTAAD commands, there is a restriction. What is that restriction? Here we should keep only the relevant STAAD file open in your machine. If you open two STAAD files, it will not run. It will create a conflict. It will not understand which STAAD file to be referred. So that's why keep it in mind while extracting data from your STAAD file through OpenSTAAD commands. You have to be careful that only relevant file is opened on your system. So okay, let's start as usual. We want to fill this table with the relevant information. So first step, insert a button. Okay, we will name it as mm, geometry. Okay, start coding. Yeah. Now, first of all, we have to define our object. That is object OpenSTAAD as object. Object. Then we have to define some variables. This is the variable cell beam numbers, that is cell beam no as long. We are going to use it for the selected beam numbers, means how many beams we have selected in STAAD. Then this is the array cell beams. In this array we are going to store the selected beams, means selected beam numbers. Cell beam pro we are going to use for storing the property property of the section, that means beam. I think it is not required. Okay, we'll see afterwards. Then we have to define a variable for length of a beam, that is beam length as double then variable to define node A as long, then node B In this node A and B, we are going to store the incidences of the beam in coordinates nodes of the beams. Then for coordinates, chord x as double three coordinates x y sorry z. Then set object first is equal to our usual syntax dot this is not a comma, this is a dot. Key inverted comma is closed. Then we will get the selected beam numbers is equal to dot geometry dot get number of beams. Small o. Then redeem. What redeem? Yes, you guessed correct. We have to set the dimension for the array cell beam beams as cell beam no minus 1 as we have defined it, no problem. So why this is minus 1, I have told you in my last tutorial also. In OpenSTAAD, for the arrays, index start from 0, 0, 1, 2, 3, 4 members, like that. Then we have redimensioned our array cell beams as cell beam no minus 1. Then we will get the selected beams stored in this array. So get selected beams and store in cell beams. Yes. Now we will run a loop to populate the data in our this table. For first let me check. Okay. Then cells I plus 1 5, 1 is equal to sail beams minus 1. Let's check whether we are going to get the selected beam numbers in this column. 5 plus I, that means 5 after 6, and this is first column. Let's check. Let me select this beam. These two beams I will select. Uh, Spelling mistake. Sorry. Yes, 5872. Let me check. 5872. Done. Next step, we will get beam section, which we have used for these beams. So what we have defined here, beam property. For these beams. Sail beam pro, and we will store it at the location not first column but at the second column, and that is sail beams. Let's check it. Yes, 254.31, 254.31. Let's check it. Yes, it is 250.31, 254.31. Okay, okay. So we have so far reached second column. Then length, beam length we will find out now. Beam length, we have defined the variable for it. Get beam length for, sorry, and store it at the location at third column. Check whether we are going correct or not. No, I have not selected any of the beam, that's why it's not pop up. Okay, So first select the beams, click it. Oh, oh. Hmm. Hmm. I have not changed the variable. Okay, 4 4. Let's check the length. 4 length. Length is 4 meter. Okay. So far going good. Now the node numbers. Get member incidence for these beams and store it in node A and node B. Node A will be the first node of the beam and node B will be the second node of these beams. Then get the coordinates for those beams, those nodes. We want to check the, okay, node X, node Y, Z. What this command states: obj OpenSTAAD.geometry get node coordinates of node A and store it in chord X, chord Y, and chord Z. So we will populate these coordinates in our table here for node A. Not 3, it's 4. It's 5, it's 6, Y, this is Z. Let's check. Okay, let's check for the coordinates. For beam number 58, it is 58. Sorry, node number 25. I'm sorry, 0, 114.3 and 0. Yes, and for 72, 4118, 11.8 and 45. $72. Sorry, I'm sorry. I'm looking at the beam number. No, I have to check the beam number 72 and its node number A. That means 43. For 114.3 and 0. I'm sorry. Yeah, it's correct. Similarly for node B, simply we will copy this again. Instead of node A, we will put node B and continue the column number as 7, 8, 9. So finished. Then set STAAD is equal to nothing. It will come out of the STAAD. Save. Select the beams. 1, 2, 3, 4. Yes. So x is 0, z is 0, y is increasing. It means it is a column, vertical member. And these are the properties. Let's try some other thing. Yes. Further, this information we can use to program in AutoCAD like Lisp and like those programming to prepare a drawing for you. So this is the programming, simple one. Thanks for watching. See you. Bye.